Okay, why don't I get started while it's recording? I'd like to introduce Dr. David Dunstan. I was very thrilled when he agreed to present to us because we don't get an opportunity to bring many people in from Australia, so this is a great way for us to do it. Dr. Dunstan is the head of the Physical Activity Laboratory at the Baker Heart and Diabetes Institute in Melbourne, Australia, and is a professional fellow at the Mary MacKillop Institute for Health Research. And then I also noticed he is also an adjunct professor at a number of different places: University of Queensland, Deakin University, UWA, and Monash University. I was like, wow, you're busy. His research program has provided substantial contributions to the evidence base on the adverse health consequence of too much sitting, or Zoom, and the potential health benefits resulting from frequently breaking up sitting time. His research program has been extremely well funded with external funding from NHMRC, which is like our NIH, Vic Health, and the National Heart Foundation. He has over 175 peer-reviewed papers, all in top journals like Diabetes Care, Circulation, etc. And interestingly, over the past 15 years, Dr. Dunstan has established an extensive media profile, including interviews with NPR, Wall Street Journal, CNN, New York Times. And so without any further ado, I'd like to say thank you for coming and let you start, Dr. Dunstan.
Well, thank you for that kind introduction, and thanks to you and Jackie for this great invitation. I also was thrilled to be given the opportunity to talk to your session today. I'll just try and bring up my... Can I just confirm that you can see?
Yep,
see
that's
that?
great.
Okay. And greetings from down under, where it's 8 o'clock in the morning, so it's not too bad. So hopefully I'm fresh enough. I was just talking about us being in a lockdown situation for a long period of time. So it's one of the first days I've actually put on a collared shirt for months now. So I feel like I'm back at work again. And actually, when I received the invitation, I was quite delighted because back in 2007, I did visit the university and was privileged to provide a presentation that Mark Hamilton and Ted Zederick had organised back in 2007. But, you know, of course, in this year where we just have a completely write-off, it's great that we can do presentations via, you know, Zoom and others. So it's nice to be back. But just before I start, I think I need to highlight that since my visit in 2007, considerable progress has been made in the field of sedentary behaviour research. And I look back to 2010 when we had our publication in ESSR, which was summarising the evidence from 2000 to 2010. And what we did in that publication is really put out the call to action to continue developing the evidence base, in particular the experimental and intervention evidence. And I think that this is a good indication that this was rather successful in terms of garnering interest. And you can see there's been an exponential rise in the number of publications since 2000 and 2010 on this particular topic. So my job today is really to synthesize the evidence that up to 2020, and I'm doing this via a review article that we had published in Annual Review of Public Health earlier this year, with Neville Owen being the first author. And again, it was 10 years on since the ESSR paper, and this review was to synthesize the evidence up and over the last decade or so. So I'm going to break my talk into 5 sections, and I know that this audience is pretty well versed in this area, so I won't need to dwell too much on some of these topics, but I just thought I'd run through that we really have got a better understanding of the distinctions between physical inactivity and sedentary behaviour. And as I showed in the slide before, a lot of evidence from observational research. But increasingly, and the guys there at the University of Missouri have contributed substantially to the evidence based on the experimental mechanisms and the biological mechanisms. But I think where we need to do a bit more work, but we're getting promising findings, is identifying potential solutions to this problem that has really been heightened with the whole COVID situation, with people having to work from home more extensively and losing that incidental physical activity. And I'll finish off with some of the challenges, and I think we still have a number of opportunities to pursue in further research. So let's just kick off with just a little bit of background, a bit of definitional aspect. And I'm sure I don't really need to talk too much about this, and we all understand the importance of regular exercise or moderate to vigorous physical activity, particularly for improvement of cardiorespiratory and muscular fitness. So, and there's also involved in reducing the risk of a number of chronic diseases. But we have starting to get more consensus in terms of the terminology, where we denote that a person is considered to be active if they are meeting the minimum physical activity recommendations of 150 minutes of moderate vigorous physical activity. Under that, we consider those folk to be insufficiently active. I raise this because, way back, the term sedentary was often used interchangeably with this insufficiently active, but I think we've moved on in terms of understanding the definitions. Just to highlight that, and I'm sure this audience is pretty well aware that we are experiencing another pandemic of physical inactivity, and this is from the WHO on the global prevalence of insufficient physical activity, published back in 2018. And I think the key summary here was that 1 in 4 people globally are not or insufficiently active to improve health. And I think that this is probably an underestimate, given that they also included occupational activity. So we have that in that background, high levels of physical inactivity. But what we have started to really appreciate is that behaviours occur across the day, from the time a person wakes up to the time a person goes to bed. That there are many opportunities for long periods of sitting in a domestic situation, and also in a social situation. This is depicting an older adult. But the key here is that people can still be sufficiently active. That is, they're meeting the minimum recommendations as they accumulate 30 minutes or more of activity or exercise across the day. But in the remaining hours, can spend a considerable proportion of the day in sedentary behaviour. So it really raises this term, the active couch potato. People can be highly active or active, but also highly sedentary. And so I think one of the big changes in thinking over recent years is understanding that there is a physical activity spectrum, and I think we're all pretty well versed in understanding the important benefits of moderate and vigorous physical activity at the higher end, and this is really what our public health guidelines are directed at. But increasingly, we're starting to observe studies showing that there may be health benefits, particularly for older adults with lighter intensity physical activity, simply moving around and ambulation, etc. But we also acknowledge that at the other end of the spectrum is sedentary behaviour. And you can see here the definition from the Sedentary Behaviour Research Network is describes any waking behaviour characterised by energy expenditure that is low, so less than 1.5 METs, while in a sitting, lying or reclining posture. So elements of the definition are posture and also low energy expenditure. So you can see here a person can spend the 24-hour or 16-hour waking day across these different activities across the spectrum. So I thought now it'd just be good to summarise the observational evidence, because there's been enormous amounts of studies that have looked at their data sets and looked at both cross-sectionally and longitudinally. But I think there's been a major evolution in the measurement methods. And just to walk back to 1995, where we can see on the bottom here, there for sitting or sedentary behaviour, self-reported methods back in the 90s was really directed at single item questions, and it still exists inside the IPAC question. But this has progressively moved to starting to look at sitting time across multiple contexts and domains like transportation, work, domestic environment. So we've really seen a progress there for the self-reported measures. But perhaps the biggest change has come with the greater proliferation of device-based measures, with the actigraph accelerometer, and for sitting per se, the device of the ActiPower or the inclinometer was really considered to be the gold standard measure of sitting, standing and lying postures. And this has progressed in terms of the analysis of the information coming from these devices, from originally just focusing on the total volume to then starting to better understand the accumulation patterns, how people could sit for long periods of time versus those that broke up their sedentary time. And over more recent years, we're starting to see machine learning methods to overcome some of the measurement error of these devices. And many studies are now starting to combine multi-devices to not only address the posture element, but the intensity of the physical activity. So we have progressed substantially in the measurement. But to summarise evidence, this is Australian study that we undertook in around about 700 Australian adults as part of the AusDiab study. And we asked them to wear these two devices, the Actigraph on the hip and the ActiPower on the thigh, over a 7-day period, 24 hours. For the ActiPower, and taking off at night time for the Actigraph. But this is just the breakdown, the mean distribution of time across those the 16-hour waking day. And I think what's most striking, and this is consistent across studies in Sweden, the US, etc., that the largest amount of time is spent sitting. And if we break this down to what we classify as prolonged sitting, those bouts that are longer than 30 minutes or more, that's around about 4 hours of the total sitting time. So a lot of time is spent in what we would consider prolonged sitting. Importantly, the remaining hours of the day are distributed between light intensity activity with a smaller amount in the moderate to vigorous physical activity. I mentioned before that we've got a better sense of the accumulation patterns, and I just want to use this example to highlight this. And this is data from the ActiPower from two participants of the AusDiab study, two participants that have identical sitting time across the day, so their volume of sitting is the same. And in the white here is when they're sleeping, obviously, and this is when they're awake. In here, you can see that this person is still getting some form of moderate, vigorous physical activity, some light activity, but you can see the concentration of the periods of red. These are sitting periods, and we would consider that to be prolonged sitting. Contrast that to the person down below, who we would define as the interrupter. Same amount of sitting, but you can see that there's absence of these long chunks of sitting time. So this person is breaking up their sitting time frequently with either light intensity activity or moderate intensity activity. So we've really come a long way of understanding not only total volume, but also the accumulation patterns. But I think one thing that we really need to get a little bit more thought on and understanding is this fundamental principle that sedentary behavioural sitting is the antithesis of total sitting by definition, because we know that if you're sitting, you're not engaged in movement or activity. So, and vice versa, if you're engaged in total physical activity, moving, you cannot be, by definition, engaged in sedentary behaviour. And to illustrate this, we recently produced this for a review article where just to indicate that there is this variation in the balance of time spent sitting versus time in the green spent in total physical activity, and broken down by light in the yellow and orange in the moderate vigorous. Person A is clearly got the balance in the right direction. They're moving more than they're sitting, whereas person B is in a balanced situation of sitting and moving. But you can see here that in person C still got some little bits of moderate vigorous physical activity, but much of the red takes up this total physical activity. So their balance is in the what we would consider the deleterious direction. So we're really starting to understand that if you change one, it changes the other back and forward. In the last decade or so, as I showed earlier, there's been a lot of evidence in understanding the associations of high sitting with increased risk of chronic diseases, and perhaps the most comprehensive review was undertaken as part of the US 2018 federal guidelines advisory committee meeting, and this is the summary of the evidence based on systematic reviews and meta-analyses looking at associations. And I think the key to understanding here is that they concluded in this review that high amounts of sitting, that there is strong evidence linking high amounts of sitting with all-cause mortality, cardiovascular disease mortality, incident type 2 diabetes, and incident cardiovascular disease, with limited evidence for some of the other outcomes. For the mortality outcomes, there appears to be a dose response, evidence of dose response, and that there is variation according to physical activity, and I'll come back to that. And so I think that this has really consolidated the evidence and given us that understanding that there is a need to address high amounts of sitting for chronic disease prevention and management. And one of the key questions that has been addressed in recent times is what level of physical activity is required to, or exercise is required to essentially cancel out the health hazards of too much sitting. And I'm sure that many in this audience have seen this paper back in 2016, a harmonized meta-analysis with more than 1 million people. So various studies contributed to this meta-analysis. Bearing in mind that this was relating to self-reported evidence. Now, this is quite a busy slide, so I'll walk you through it. What they have created is these categories of physical activities, from high amounts of physical activity down to lower amounts of physical activity. And this is broadly representing what the amount of physical activity, moderate activity per day, is inside these categories. And then within each of these categories, they were able to identify 4 categories of sitting time, from low right up to high, and that goes across all the physical activity categories. Now, important, the reference category here is at the most desirable and high amounts of physical activity, and also low amounts of sitting time. I just want to direct your attention to this side first, and I think this is not unsurprising that low amounts of physical activity and high amounts of sitting is where there appears to be the highest level of risk. But inside this data, and this has been shown by others as well, this is at the level of what the current minimum recommendations is for moderate and vigorous physical activity. You can still see that even at that level of physical activity, there is a dose response for sitting time. And similarly, again, at higher levels, there is some, albeit a bit more attenuated, with even higher levels of physical activity. The conclusion, the main conclusion made by the authors was that at very high levels, so this is the 60 to 75 minutes per day. Remember, this is 2 to 3 times more than the current recommended levels. That's where you start to see that attenuation. So yes, very high levels of physical activity may afford that protection from high amounts of sitting. But at lower levels of physical activity, particularly those who are physically inactive, the risks associated with too much sitting, there's a dose-response relationship there. To make it easier to interpret, Peter Kaczmarczyk and his group produced a heat map based on the Eklund findings that I just showed you, and it's quite obvious here that the more moderate physical activity that a person undertakes, the more favourable that is in terms of illustrated by the colour green. The opposite is true for high amounts of sitting and low amounts of physical activity. But in the task force, the US Federal Guidelines Task Force report, they really emphasise this point that the risks of high amounts of sitting are most pronounced in those who are what we would consider physically inactive, that is not meeting physical activity guidelines. And hence we need to direct our attention at those who are physically inactive, but also sitting for higher amounts to improve health. We've taken this a little bit further, and I'll just quickly go over this by using the heat map example to put it into a risk matrix to really emphasize that we need to, in clinical settings, particularly for those with chronic disease, get an understanding of a person's physical activity level and also their sedentary or sitting time level, using simple questions like this, and using this matrix to try and transfer people to a lower risk profile by either increasing physical activity or decreasing the sitting time. But preferably, of course, the best is moving people on their physical activity and also lowering their sitting time. So it's just an illustration that we can transition people by attending to both physical activity and sedentary behaviour. So before I move off the observational evidence, I just want to highlight that there has been some studies and that have looked at not only the volume but also the patterns of sedentary time. And Keith Diaz has produced this figure for all-cause mortality, where it was shown that increasing the duration of the sedentary bout was associated with a higher or elevated risk of mortality risk. They then used the same data set to look at some reallocation analyses. So reallocating, hypothetically reallocating 30 minutes of sedentary time to light intensity lowered the hazard ratio. But of course, greater benefit was observed from transitioning sedentary to moderate physical activity. And when they looked at the prolonged periods of sitting and transferring that to light, there was similar associations observed. And finally, John Bellatier in San Diego, in older adults, has um, using device-based measures of sedentary time, have shown that as the duration of the sedentary bout increases, so too does the risk of cardiovascular disease. So there are some evidence, some studies showing that the patterns of accumulation may also be important. So what I've highlighted there is some extensive evidence from the epidemiology, but I think one aspect that we really pushed in the annual reviews paper was that we really need to move beyond the constrained boundaries that exist with epidemiological research and start to bring in evidence from other disciplines of research, and in particular the clinical and experimental and intervention. So to triangulate the evidence and to really build the evidence base further beyond just epidemiology. And I'm pleased to say that there's been a lot of activity in this area of experimental research, and I just highlight that back in 2016, Paddy Dempsey, who was a PhD student of ours, and John Tiefel, who I know as a former colleague of many of you there, just put forward hypothesized mechanisms and potentially, where the evidence gaps are, and the evidence gaps they identified here in red, but just highlighting that there are likely to be multiple biological mechanisms, but we still have a lot of work to do to better understand or elucidate these mechanisms. But I think one key message here, and this is often confused by reviewers of papers, is that when studying the health hazards of prolonged sitting, by definition, the countermeasure of sitting must be physical activity. That is, any bodily movement produced by the skeletal muscles that requires energy expenditure. So this could be from standing to light activity to moderate activity. And I think this is a really important point, because many studies have started to experimentally impose periods of prolonged sitting, and these are just examples of studies that we've undertaken in our laboratory, where we invite participants in to sit for a period of 5 to 8 hours and feed them throughout. But we contrast that prolonged period of sitting with interrupted sitting. So building on the evidence from the epidemiological evidence that I just showed, is to try and break up that sitting time through the accumulation of brief bouts of activity, and this is ranged from standing right through to moderate to vigorous physical activity. So it's that contrast of the active state to the prolonged sedentary state. And I just want to, there could be a number of studies to highlight, but I thought I'd highlight this work that we've undertaken in people with type 2 diabetes, and it was Paddy Dempsey's PhD research, where we used a 7-hour protocol. And I just highlight that we used 2 different types of active break conditions. One was light walking, and the other was what we can call simple resistance activities. And the reason why we did this, and you can see here, this is just one of the activities. They just did this for 3 minutes, and they did 3 different exercises to try and engage the large muscle groups. And importantly, the advantage of this is that it can be performed in a static position, so people could still perform this while still interfacing with a computer at work. And we did some pretty cool work recently. This is very much pilot work, where we had a Finnish researcher visit our lab and brought along the EMG shorts to measure the electrical activity of the thigh, hamstring, and also the gluteals during different activities. And you can see it's not surprising, sitting, very little activity happening. And of course, when you start to jog, you got a substantial amount. But when we put people through the simple resistance activities, you can see that there's strong engagement of those large muscle groups, particularly the muscle groups of the thigh and the gluteal. So it's really about enhancing that skeletal muscle activity more frequently throughout the day. And I guess perhaps where the strongest evidence for the breaking up of sitting time experimentally is in the area of postprandial glucose and insulin metabolism. And this is just the example in people with diabetes. In the open circles here is when they undertook the prolonged sitting condition. And remember, this is a crossover design, so each person went through all three experimental conditions. But if you can see here that there is quite a substantial attenuation of the postprandial glucose with the light walking and also the simple resistance activities. And this translates to a 39% reduction for glucose, and similarly for insulin. For triglycerides, there was a reduction, but it was largely from the simple resistance activities that was observed. And finally, in this same study, one of the secondary outcomes was blood pressure measured periodically throughout the experimental design. And you see here's the prolonged sitting, and we can see that there is an attenuation in both systolic and also the diastolic blood pressure, which is quite a substantial difference between the prolonged sitting and these active interruptions, which this needs to be confirmed in other studies, but it's really quite promising that these sort of daily activity interruptions may be beneficial, particularly those hypertensive individuals. So you can see we've published on this recently in 2018, just to put forward some of the proposed mechanisms, and I won't go into great detail here, but importantly, when you contrast to a prolonged sedentary state, the active interruptions leads to improvements in many of the potential mechanisms for underlying benefits for blood pressure. And more recently, and I think Sophie Carter, who we've been working with this on this, is to summarise the mechanisms of that transition from a sedentary state to an interrupted state, and showing that there is an interplay between various biological mechanisms. And I know that the group, Jame's group there, have contributed substantially to understanding the influence of breaking up sedentary time on vascular function. So just to move on now and start to put the evidence into action, we now really want to start to look at looking at solutions. In Australia, we've had some broad recommendations on sedentary behaviour included in our physical activity guidelines since 2014, but increasingly we're seeing leading health agencies like the American Diabetes Association, European Society of Endocrinology, all incorporating broad messages that in addition to physical activity, addressing sedentary time is important for management and treatment. And the American Heart Association also put out this paper in 2016 with the broad message that it's appropriate to consider sit less, move more. But since over the last 5 years or so, there's been an enormous amount of work undertaken in randomized controlled studies to look at interventions to reduce adult sitting time, and even to the point now where we have systematic review and meta-analysis that came out earlier this year. And in that study, they were able to identify 35 studies. And when they broke it down to studies that simply just changed the environment, so most likely this is the incorporation of height adjustable workstations in workplaces, versus those studies that were multi-component, that is adding an environmental aspect to a behavioural aspect, and also often a policy change in workplace. And these are the summaries of the changes that have have been observed with the breaking up, the reduction of sedentary time. Most of these studies, I should emphasise, have been undertaken in a workplace context. And more recently, although that systematic review has shown that it's feasible to induce change, what are the likely benefits for markers of cardiometabolic risk? And we addressed this in a systematic review that was published earlier this year, where we were able to identify 33 studies. And the summary was that at the moment, the evidence shows that very small, quite modest effects of the sedentary behaviour reduction interventions. And you can see here a summary for the adiposity measures, blood pressure, and some evidence for improvements in fasting, insulin, etc. So, yeah, small changes have been observed so far, and some of the evidence gaps that we've identified is that we really are lacking studies that are of longer term. Most studies are 3 to 6 months, and we need to start to focus beyond just the workplace setting, and studies are already underway to look at that. And the other thing is that often in these studies, the biomarkers are considered to be secondary outcomes, and therefore studies are not adequately powered to be able to ascertain change. And we also, most studies have been undertaken in lower risk populations, and we really need to start to look at what is the benefit in more clinical or higher risk populations like type 2 diabetes. And that's what we're currently undertaking here in Melbourne. A study looking at office workers with type 2 diabetes over 12 months, an intervention. And just now maybe moving more towards applying the knowledge. And I think if we use the context of people who are at elevated risk of chronic disease or with chronic disease, physical engagement in regular physical activity can be often challenging because there's many barriers through having multiple comorbidities, etc. And this is a paper that we've been working on with Shilpa Dogra in Canada, where we are putting forward a proposal that perhaps in those that are really struggling to engage in regular physical activity, perhaps an initial step could be to focus on the reduction of sitting time in a first instance, and then progressively moving up the steps to obviously work towards what we would call that health enhancing physical activity, including improvements in cardiorespiratory fitness. But I guess above all, we now need to start thinking about sitting less and moving more for health promotion. And this is already starting to emerge in, for instance, the 2018 US federal guidelines has got messaging along those lines. But we obviously don't discount the important benefits here, but I guess that through a staircase approach, it can be a more gradual approach than the traditional one-size-fits-all of attempting to take a person who's sitting a lot, not doing much physical activity, and transfer them up into the higher levels of physical activity. So finally, I think I've synthesized the evidence to date, but I think that we still have a lot more work to do. And if I use a traffic light color code to identify where we have some reasonably good evidence is in the epidemiology and fairly consistent evidence in the clinical or experimental studies, we really are lacking evidence from long-term interventions across multiple settings. So I think in our annual reviews of public health paper, we summarise where there are some future opportunities and where some of the evidence gaps exist. And I think one aspect that we really need to start to see in the future is the use of device-based measures to look at prospective relationships between not only the volume of physical sedentary time, but also patterns of sedentary time and chronic disease risk. Another aspect is to look at the observational and experimental studies and sedentary behaviour patterns, and moving beyond the traditional metabolic markers that we've focused our attention on, to start to look at other health outcomes like musculoskeletal health and also mental health. We are also lacking a lot of evidence, particularly in older adults, those with multiple clinical conditions, and understanding the relationships with these really key chronic diseases. And finally, the last 2 points is to start to think about behaviour change interventions in different contexts, so moving beyond just the work sites or a combination of work sites into domestic environments. And this is going to be brought about by having stronger partnerships with employer and employee representative groups across government, etc., to really start to shift the cultural aspect around sitting, particularly in workplace settings. So I'll finish up there, and I hope I've been able to give you a flavour of where the evidence exists at the moment, and of course where the evidence gaps remain. So thank you very much for your time.
Oh, that was brilliant. Thank you very much for that talk. And
I might.
And Gavin, are you there? Are you monitoring chat?
Yes, I'm here, so I can take that away.
Okay.
Okay, Dr. Dunstan, thank you for a great talk. I was very excited to see your name down on our seminar list this year. So I'm just going to go through our questions now on our chat. So first question is from James, and it is, to his understanding, it is that while accelerometers are widely used in physical activity assessment, they are not good at picking up non-ambulatory motion, i.e. resistance training. How can this challenge be overcome moving forward in trying to improve physical activity assessment?
Well, thanks, James, for the question, and I firmly agree with you that it does have a lot of its measurement considerations, and you raise a great point about resistance exercises is essentially missed out because lacking the acceleration aspect. I don't know whether I can offer the solution just right now, but I think we extend those problems with the accelerometry into the area of sedentary behaviour and that light intensity or standing, where there is still some dispute over whether the accelerometer is truly picking up true sedentary time. So I think that we have, and we're starting to see groups like at San Diego and the group at Oxford starting to use machine-based learning to start to improve that. So I know that they're also starting to look at machine-based learning to address that issue that James, you raised on the resistance exercise. So I think we are going to see it get better, but it is going to take time as groups start to understand the evidence from the machine-based learning.
Okay, so the next question is from Dr. Elizabeth Parks. She says, please let me know if this is out of the scope of your talk, but I was wondering if activity in earlier midlife accommodates sedentariness with aging. Do you know what I mean?
Can I stop
Sorry,
working out?
Gavin, that just broke up a little bit.
That was a bit of a mouthful, that word, sorry.
No, I would like to know if I was active early, can I stop working out now? As I age.
Well, I think that I would not want to be conveying that message. I think that we know, and we've got decades of evidence showing that that exercise that you've been undertaking is clearly beneficial for health. And I think what we do see is that yes, we do get benefits from light intensity activity, but of course we get greater benefits from the more moderate intensity activity. So I'd be strongly encouraging to just be thinking of, you know, maintaining that exercise regime that you have, but also move more frequently throughout the day.
Yeah, need to. Thank you.
Okay, the next question is another one from James, and it's quite a long one. So, and it's a lead on from his previous question. So he's cited a paper and he's read it in the past, and he was saying that the authors posit that physical activity assessment is intrinsically difficult as both subjective questionnaires and objective accelerometer pedometer forms of measurement present their own unique challenges. How can the field of physical activity assessment overcome these challenges? Does it require technological advances, or is there scientific rationale that we can apply to better interpret the data from these forms of assessment?
Wow. I think I addressed that a little bit in the earlier question, where we're starting to see groups using machine-based learning to better understand the patterns that, or the signals that are coming out of the accelerometry, etc. As for the subjective measures or self-reported measures, I think I've highlighted that we have seen some positive progress in those measures, particularly for the sedentary, moving beyond just a simple question, relying on people to estimate their total sitting time across a day or a week. But I think one key point is that I think we really need to use both in combination, because one of the gaps that we have that is likely to be particularly important as we start to develop up interventions is understanding where the sitting is taking place or where the physical activity is taking place. That is the context, which you simply cannot get through the accelerometer and also the active power. So I think that the questionnaires or the self-report helps us to better understand where the activity or inactivity is taking place. So I think that we need to start to really not throw out you know, the great work that's been done with the development of the measurement tools, but start to use them more efficiently and in combination.
Okay, we have a question from Dr. Limberg. Are there any data from the intervention studies showing an effective breaking of sedentary behavior on sleep, or 24-hour biomarkers of blood pressure, cortisol, urine, catecholamines? And then she adds, it looks like the majority of data is in middle-aged older adults. Has a similar model been applied to children in terms of breaking up sedentary behavior?
Yeah, I'll answer the first part. Yes, most of the studies have been directed at adults, and as I emphasised, for the sedentary behaviour reduction studies, most have been focused on the workplace setting. In saying that, there has been emergence of some studies that have started to apply similar protocols in the school environment. That is replacing the traditional, you know, sitting, you must sit for all the class period, to having height adjustable workstations or incorporating more movement in the learning experience. And yes, I think we've seen that feasibility of change is it's not as great as in the workplace setting, but we are starting to see that we can get changes in the classroom setting. I think the challenge in the younger age groups, if we are wanting to look at changes in biomarkers, for instance, remember these kids are pretty fine-tuned compared to us adults, where things start to go awry. So we need to start to look at more innovative, markers that could be subject to change with such interventions. And then I think the other part of the question was the 24-hour ambulatory. the answer is no. There's been a few studies here and there, but most studies have focused on what we would call the traditional biomarkers. I think mainly because of the logistics involved. For instance, in a workplace setting, it can be challenging to incorporate those measures. But I think what you do is highlight where we still need to get more evidence, looking at other markers of chronic disease risk.
We have a question from Talia Fordham. So she asks, do HR measurements or heart rate measurements like those from Fitbit and Apple Watch and data from accelerometers provide a better picture of active time versus non-active time? So I think she's
Yeah, no, it's a really interesting question, and we're starting to see more and more of these commercial devices having heart rate monitoring. I think one of the challenges there is that heart rate has multiple influences. For instance, stress, food, etc. So there is likely to be some error involved there, but with the activity side of things, we're just doing some work looking at some of our Fitbit data and trying to understand the algorithms that are being used by Fitbit to denote what is moderate, what is light. It's like a virtual black box. It's very difficult to understand how they use the heart rate and the movement to be able to denote different changes in intensity of physical activity. But I think one plus for the Fitbit monitors, and I don't know whether groups are using the software like Fitterbase software, which allows people to be able to monitor almost in real time people's physical activity levels that are wearing a Fitbit. The heart rate data does allow us to get a greater understanding of when the monitor is not worn. Because when there's no heart rate signal, we clearly know that it's been taken off, or we have to start to really worry about that person.
Okay, and Dane asks, seems like low-hanging fruit, but has anyone correlated sedentary behaviour with screen time?
With screen time?
Screen time.
Oh yeah.
Screen time. Well, that's a major topic of conversation, and in fact, just the last week or two, the Canadian 24-hour guidelines incorporated actual messages around screen time for adults. They've been so bold to put a 3-hour limit on screen time, in addition to reducing overall sedentary time under 8 hours. As for correlation between sedentary and screen time, we do know that screen time does lead to a lot of sedentary time, but I'm not. It's not jumping out to me whether it's actually been, correlated. I don't know whether others on the audience might know a bit more than me.
I thought I've seen that before, and for some reason I thought I saw it done in children.
Yeah, and that's where most of the work has been done.
Yeah.
But I guess what we do know is that sedentary behaviour is highly inversely related to overall physical activity levels. So I think we could safely assume that the screen time would be highly correlated.
I have seen some studies using screen time as a proxy of sedentary behavior.
Ah, yeah.
Yeah. Good to see you, Dave.
Oh, it's great to see you. I was wondering when I was going to get a question.
Yeah. Good to see you.
Okay, we have one more question on the chat. Oh, two more. You're very popular, Dr. Dunstan. Okay, so this is from Neil, and he asks, you've spoken a lot to the notion of getting people to move as step one, which he agrees with. It appears that 10,000 steps a day has been widely accepted by the public. especially with the innovation seen in wearable devices, perhaps even prioritizing it over moderate exercise. What is your opinion on this benchmark for ambulatory movement?
Yeah, I think you're correct in saying that, the public has really warmed to the 10,000 steps. But I think the threshold of where the health benefits start to come in, there's still some debate over whether, it is the 10,000 steps, because I believe that it's not entirely empirically based, that 10,000 step number. And I know that Katrine Tudor-Locke's been doing work where they've identified that benefits can be gained from even lower levels of steps throughout the day. But I think what we're starting to see in, for instance, the US guidelines, Australian guidelines, is these rather broad messages of, sitting less and moving more at any intensity. And I think that that's appropriate given the epidemics of sedentary behaviour and physical inactivity at present.
Okay, and Dane wants to extend Neil's question and asks, he refers to 150 minutes of moderate exercise per week. Specifically, why 150 minutes per week?
So this is the recommendation based on observational evidence and experimental evidence that has shown that that's where the health benefits really start to improve substantially compared to lower levels. But I think one thing that has been highlighted in the more recent 2018 recommendations is that from a public health perspective, the greatest benefits that are likely to be derived from taking a person that's doing nothing to doing something. And we see really sharp declines in risks for a number of chronic conditions as people transition from the 0 minutes per day per day to doing the 5 to 10 minutes per day, and increasingly so beyond 30 minutes and or more. So the 150 minutes is not my doing. It's existed in public health guidelines for a number of years, and it's a fairly consistent message across the globe.
It's actually been extended to 150 to 300 minutes by ACSM in the past year or so, because to get better results.
Can I ask you a question about your job and our job? Academics in particular.
We cannot hear you, Elizabeth.
Sorry. Now. Can you hear me now?
Yeah.
No?
I'm sort of going to guess your question is that workplace setting, academics spend a lot of time interfacing with a computer, and I think that we are in a bit of a more privileged industry in that we have the discretion to be able to move around, as opposed to industries like call centers, for instance, where that discretion is removed from them. And I'm sort of guessing your question, but I guess I think that we need to see a shift in the norms and the culture of how we work, and in particular as we start to work from home more frequently, in trying to incorporate more movement throughout the day.
I'm going to hold it up here.
I hope I guessed all right.
Yeah, I'm going to hold it up here because we're at 1 hour, but I really liked your message that we need to be doing more of these studies in these high-risk populations, because I know as a reviewer, I see so many in the healthy individual where it's not really where our primary concern is. And I'm also very interested in, even in an older individual, they become very sedentary, and if we can really protect them so they maintain their activities of daily living, I think a lot, it's also an area that needs to get tapped into considerably more.
Yep, I firmly agree.
It was a brilliant presentation. We definitely appreciate your time getting up early. And can everybody unmute? And let's give Dr. Dunstan a round of applause.
Thank you.
Thank you very much.
Thank you for the opportunity, and all the best to everybody, and stay safe.
Yeah, stay
Thanks,
healthy there. And I'm glad you're going into summer. Might make things easier.
All right. See you.
Thank you so much. That was
Bye.
wonderful.
Really good.
Thanks, Yanni.
Bye-bye.
Bye-bye. Yes.